Okay, welcome back to my channel. Hope everybody's doing good today. I've been working on a Denso alternator off of a 2014 Honda Odyssey. I showed a video. My previous one was how to disconnect the stator leads by snipping the solder joints so you could get the alternator apart. Well, now I've got it apart, and the slip ring contacts on the rotor shaft are worn out. So I've never done this job before, and I didn't search a whole lot to see if there was any instructional videos on how to replace this. So we're gonna make a video, and hopefully we can get this thing replaced, and you can follow along with me as I try to figure out how it is replaced. So I'm gonna flip the camera around and show you where I'm at. I've got the rotor out, so I'll be right back. Okay, so we're back, and I have the rotor out, and you can see all this wire. It looked like this. It's worn into it. So this alternator, the particular vehicle it's on, had an oil leak, or still does have an oil leak. I haven't addressed where it's at. I ain't even found it yet. This is on my daughter's vehicle. But we are going to go ahead and repair this alternator, and you can get these rebuild kits. And this is the new slip ring. You can see, badly worn. You know, sometimes they're a little bit worn, but this is just excessively way too deep to try to reuse this. So this is the one to replace it with, and so I've got to figure out how to get this old one off, the new one on, and get them reconnected. So I started, before I started the video, I started tinkering with it, and there's some epoxy compound. It looks like epoxy to me that they sealed this up with where the connections are. But I've got this little screwdriver that just comes in handy for all kinds of stuff. I'm gonna try to chip this away, and we'll see what we have underneath here. Get to the connections, because I can see one of the connections. Here, let me turn this a little bit so you can kind of see where we're at here. You can see one of the connections right here, and there's one on the opposite side. So the first order of business is to get this epoxy cleared away. I know my hands are probably getting in the way, and I'm trying to keep it to where you guys can see, but it's really just chipping at some epoxy. I may end up getting the Dremel tool and using the Dremel tool on it to clean that out a little bit. I'd like to knock the bulk off of it right here, because we got to get to that tiny little connection down in there. Then figure out how to get it loose and put the new one on. This has always been my style. I just like doing things myself, and I haven't ever paid anybody to do any mechanical work for me. I've just always liked this type of work. I've been working on vehicles and doing mechanical stuff my whole life, pretty much. My dad was a mechanic at Ford for a little while, and he showed me a lot of stuff, taught me, you know, the basics of how to work on vehicles, but as I've went along, I've just dove deeper into stuff that, you know, I don't necessarily know how to do it. It's usually a learning process for me. But hey, when I'm done, I've learned something. And then the next time I need to do an alternator repair, such as this one, I'll know how. Well, that one worked out pretty good. I'll spin this around so you can see it. And I'm left-handed, so it's easier for me to work on that side of it anyway. So I've got that one pretty clean. Let me make sure you can see that. Let's see here. Yeah, it's kind of blocking that. I'll just let you see it like this. You can see that's the connection to the windings in the stator, or the rotor, I'm sorry. So we got to get, you can see the conductor coming out of it where that's crimped around it. So we got to get that stuff cleaned out so we can get in there and take a look at that and see what we need to do to get that disconnected. And we're not really going to try to save this piece right here, so we're just going to beat this sucker off. May even cut it. I know this is probably boring. I probably should just stop the camera and get this chiseled out of here. Personally, I like the videos where I get to see the whole process. Oh yeah, we're getting somewhere now. This is probably not the best tool to be doing this with. I've got a chisel here I've done some fancy grinding on. It's probably much better. Oh yeah, that's getting the job done. You just want to be careful around this conductor. If you break this conductor, then it's game over. Game over. Not necessarily worried about the old slip ring, but you do not want to damage the conductor. You can see it, it's small too, so it's going to be delicate. If you break it, might as well start over. Get you a remanufactured alternator. Got one little chunk in here. It's been a pain in the butt. There he is. Let's digging some of this out. Blow chunks everywhere. It's like a little, there's like a little pocket down in there for the I've about got this side cleaned out enough to where I can show you what it looks like cleaned out. And then I'm gonna pause and do the other side. And there's a little bit of insulating material that's sticking above this to insulate this from the fan on this rotor. So you don't want to go too deep and try to get it all. You just want enough to where you can work with it. Once you get it down so far, you can pick a lot of this out by hand, I'm thinking. That's what we're doing. Cleaning some of it out by hand. Here, let me let you see that. You can see I cleaned all the material out. So I'm gonna pause the camera here for a minute and I'm gonna do this side here. I'm gonna get it cleaned all the way out. I'll be right back. Okay, so I'm back and I've got all of the compound cleaned out. Can you see? Okay, I took my handy dandy little flush cuts and I cut just right here on this side of the conductor and cut the bend out right there, that fold. And that allowed me to go in there and take this tool and just go in like this and just twist a little bit and free that up. Hard to see, but there's the conductor back in there. You can see it. So I'll demonstrate that on this one. I'll try to do it to where you can see. So I'm using these flush cuts with the flush side. Just make sure you don't go any farther. No, don't go below that little crimp connection with the tip of your tool and just snip it. And so you got to make sure you clear you don't want to cut the conductor. And you can see the conductor back inside of it. So we'll take this little tool and we'll just Go right in here, like so, and twist this a little bit. Just needs to be opened up a little bit. So we got that opened up to where the slip ring should be ready to come off. I'm gonna check this one more time. Make sure I have it right. Make sure you guys are still on the just a little bit of pressure on it. Just enough to open it up. You can pry up on it and see if it's loose. You do have a little bit of room. Okay. We got that one freed up. That one's freed up. So now we can take a screwdriver so we don't have to worry about our wire anymore. Because as you can see, it's free. We'll pry this one up as well and clear that conductor. Because out of all this, that's one thing you don't want to do is break that conductor. You do not want to do that, because it'll basically render this rotor useless. So as I said, we're not trying to save this. So we're just gonna do what we gotta do to get it out of there. That's what we're gonna do. We use some needle nose pliers on it here because there is a conductor inside of this, so we're just gonna attempt to roll it right up out of there. Just like that. Do the other side the same. Get your needle nose, get a hold of that conductor right there, and roll that rascal right up out of there. Just like so. It's junk anyway, so don't have to try to save it. Now, got to figure out how we get this slip ring off of this shaft. And I have an idea. I don't know if it'll work. We're gonna try the trusty channel lock joint pliers. See if it'll turn. Look at that. Look at there. There's one piece of the slip ring. Don't damage the shaft. And I'm not really putting a whole lot on it because that's the plastic that this piece was made out of. It's the material. And you can see right here, this one's so worn that it's just gonna come off in this little ring. It's like it's cut in two. See if we can get on down here on this other half. And we'll take this little chili right here. See if we can't hit up on that. get some of this compound off of this shaft right here. I don't know. It's like some sort of plastic or something that Bakelite insulating type media. You can see how thin, I mean, look at how thin that is worn. So when you see one with a deep groove wore in it like that, yeah, it's time to replace that or get you a remount on your alternator if you don't really want to do this process right here. We're going to try to cut this one. There we go. That's how you rope her off of there. Now, look at us go. Okay, we're back on the alternator again. I will show you guys something. The slip rings that came with the rebuild kit is not the exact right part, so I had to do a little modification on it. So let me see if I can figure out how to flip this camera around, and I'll show it to you. Okay, so you can see the slip ring that I got has this piece molded in on the bottom of it. You can see that. So I started on it and I kind of took a Dremel tool here and I just cut a little. We got to remove this piece and I'm going to show you why. Get the rotor in here. I also had to modify the ID of this. It was small. It was like for a Denso alternator model with a spline shaft, and it was much smaller than this, so I had to open this up. As you can see, it slides down in this keyway, and you can see this. I'll flip it around here, maybe you can see a little bit better. You can see that this little base they've put on it is not going to work. It's going to interfere with where the bearing rides at. So the plan is this part here is correct. So I'm going to cut this piece here off smooth right here and file those down good, and then I'll be right back with you and we'll see how it fits after that. Okay, I got it. Done some modifications on it. I had to round this just a little to match the radius and the groove on the shaft. So if you do this, one thing you want to keep in mind is take the very minimum amount you have to, because if you get into this conductor on either one of these, thing keeps getting out of focus. Here we go. Anyway, if you go too deep right here, you'll get into this conductor, and if it shorts out on this, it won't work properly. And so we bored this out. So the plan is use some JB weld Because I mean, honestly, if this alternator quits working again after 100,000 miles, then we're probably just gonna put another one on it. But I looked all over the web trying to find the correct slip ring for it. I just couldn't find it, so I modified this one. So now it fits down on that. Then it's a good snug fit when it goes down into the grooves to match up this base. I can get it, you can see it likes a little bit going in, but it will actually go down to where it's flush. Where it's flush here. Flush on this where the bearing seats. So the bearing being on here will help hold it in position anyway, but we're still gonna do a little bit of JB weld between the shaft and this slip ring housing. And I'm gonna go ahead and clean all that with alcohol. I've got the groove all cleaned out nice and clean on it. I've cleaned both of these grooves out real good. So we'll clean this up real good with some denatured alcohol, maybe a little brake clean on it to get any kind of oil residue off of it. And then we're gonna JB weld this in, making sure that when we go down over it that we get the conductor here. Make sure that conductor comes up through this crimp right here on both sides. And then we'll just take some pliers and we'll mash that crimp nice and tight, and I'll probably put a little solder on it. And then we can fill this up with epoxy, which is how it was. So we'll put it back like that, and then we should be, after that, we'll be close to go ahead and reassembling the alternator, and I'll do a video of that too on how to solder the stator windings back to the rectifier. So give me just a little bit and we'll be right back after we get this cleaned up real good. Okay, I got it now, so we can test fit it. As you can see, I did a little bit of work on it. Now we slide it down. Of course, we ain't right on the, we ain't dead on the wiring, so there and there. That's basically coming up in between just as we need it to. This one as well. And we push it down. It's flush there, so we're good. So we'll mix up some JB weld and JB weld this. Hopefully it works okay. Yep. That's what we're gonna do. Mix up some JB weld. And I drilled this out with, like, this mic's 350 thousandths, and there's really not a standard drill bit to get you exactly where it would be a press fit on that shaft. So I drilled it to 358, which is a T letter bit. And I chucked this up in a lathe to get a good center so it runs true to the rotor. So that'll be enough JB weld between the shaft and this slip ring to secure it on there. So that's that's the next step. We're gonna JB weld this on. I'll mix up some JB weld and I'll be right back. Okay, we're gonna mix up some JB weld. Won't take much. Poke the tube. So we'll put us a couple of equal parts out here. We won't need much. Something like that. I always thought this JB weld was some cool stuff because it's really good. It's really good stuff. We'll get this all mixed up. This stuff sets in like 6 minutes. And it takes like 4 to 6 hours for it to dry, so we'll have to wait, come back after it's dried. But I think we can get it done in 6 minutes, I'd hope. So we're just go ahead and put it inside of this piece. We'll put a little bit on. We'll put a little bit of it on the shaft itself, but not much. I don't want to make a big gooey mess out of this thing, so. I want enough for it to squeeze up out of there. We'll coat this inside really good. I think that whenever I drilled this ID out just a little bit, when I drilled it out bigger, I think it's gonna be getting pretty close to exposing the slip rings on the inside. I can't see them, but they may be close, so I'm gonna go ahead and coat the inside of this real good because it's pretty decent insulation too, so that's what we're gonna do. I'm gonna build it up some right there so it gets in that slot in the shaft. Build it up on the same side as these where they slide in. Let me flip this camera around. And we'll put a little bit on the shaft here. Just get a good coat on it so it bonds well. Whatever squeezes out will clean off. I want to put the rest of what I got right around this base right here. so that it fills out. There's a little void at that taper. So we want to try to get that filled up as best we can. I can make a mess with this stuff with the best of them. Let's turn it over because we got it the wrong way. There we go. And now we'll just push it down. Make sure it's all the way down. It's over both of the conductors right there, which is exactly what we want. Well, we didn't make too big a mess. Oh yeah, that'll be excellent. We'll fill that void right there. I'll just give it some extra support. I mean, it turns inside the brushes and there's not a lot of resistance there. So it's not going to take a great deal to hold that in place. I want to get this out because if you ever have to take it apart to do a bearing replacement on it, you always want to get a punch that fits down inside of these, because if you hit on this outer edge here, that's going to be your plastic insulating material, whatever it may be. I'm sure it's made out of different materials and depending on the brand of the alternator, but you want to always use some kind of smaller punch that fits down inside of that. We'll clean that up real good, just like so. Look here. Better get that little bit off of the ring. We don't want anything on the ring. So I think that'll do the job just fine. I think that's going to work great. I might let that set up a little bit, but probably more than likely I'll just take some sandpaper and clean that up and just let it dry good, and I'll just take some emery cloth and sand that down smooth so the bearing fits properly. We'll take a little excess off of it right now, so there's not so much to clean up. You know, sometimes you just gotta do what you gotta do to make things work. And that's the fun of it. You know, see if you can make it work. Do with what you got. Do the best you can and move on. Okay, well, here, let me get the camera off here and I'll show you guys what it looks like on the end. So here you can see the end of the shaft. You can see we got plenty of JB weld in those slots. You can see the actual shaft here that I was talking about earlier, about how to use a punch on it when you're disassembling the alternator. Sometimes you have to use a punch and knock this bearing and all out of the cover. Other times it just comes off pretty easy. The bearing will come out of the housing and then you can use a couple of screwdrivers and sort of get under the bearing at this angle right here on each side and pry the bearing up off of it. But that's it. We'll just go ahead and I was going to show you here The inside of the alternator itself, it's pretty oily, still greasy. I cleaned the outside and I'll clean underneath that. And you got this little shim here, the spring washer, and you take it apart, you know, make sure that goes back in there between the housing and the bearing. Don't forget that, it's very important. Preloads the bearing. And you can see the stator windings here, where you can see how they're oil stained. We'll clean that up. You got to get these really clean, which they're clean right now, but they need to be really, really clean so that the solder sticks and flows good. You can use a little bit of flux. And these are the ones that really need to be cleaned. These are terribly oily, so you got to clean all that up. But we'll give this slip ring some dry time. Probably it says 4 to 6 hours that JB Weld is cured fully, so we'll give it at least that, and we will come back and continue on. Okay, we're back here. We're going to put a little bit of soldering paste, just a little, not very much, just a tiny bit. Put just a little bit where our connections are going to be. It's all clean, but it's not going to hurt anything to put a little bit of flux on it. We'll see if we can get this soldered. Soldering is it's important to get the parts the right temperature before. If you don't get them hot enough, the solder won't flow, and you'll have a cold joint. Get our iron hot first. It's just taking a minute. All right, we got a hot iron now. You can see it flows nicely. Hoping you can see this one. Yeah. Let's get it right on the conductor right there. There we go. Let's do just a little bit more on that one. I still feel like it could use some. Yeah. Let's make sure we didn't get it run down. And let's put a little light on it so we can see the subject. Oh yeah, looks good. So I have microned this out once already, but since we've done the soldering and the soldering is done, I'm gonna do one final test to make sure that we have no grounds, no contact to the metal housing or anything on the rotor. I don't know if I can get it to where you guys can see this meter or not. I can do this one hand. We'll give it a try. Get the meter in the picture here where you can see it. This meter's just set to ohms. And I have a handy little alligator clip here with my fluke meter. Maybe that'll help me be hands-free. We should read a nearly zero resistance measurement on one of the rings, and then we should read across the windings in the rotor on the other ring. So it looks like that one's reading across the windings is 2.7 ohms. This should be basically 0. 0.2, that's the resistance of the leads of the meter. And so we'll leave that where it's at and check it to ground. Ground at the end of the shaft here. No ground. We'll check it to ground right here on this nice clean metal. No ground. We'll change sides. We'll grab the other contact. We're probably touching the metal right there. Let's get off of that a little bit. Make sure we're not. We might have got that solder. Might be a little bit too much solder in that one. We'll see. There we go. That's more like it. All right, we'll check this ring. Yep. 2. 2.3 ohms. That one's reading through the windings on the rotor. So looks all right. I think we did okay. So I'm gonna go ahead and mix up some. I think I've decided I'm just gonna use some JB Weld to basically insulate this, and that'll help with the vibrations on those connections. That's how it was when we disassembled it and dug all that out. It had epoxy on it, so that's what we're going back with. I'm gonna get the camera, see if I can fix this camera. So we're just going to use this same epoxy, or this JB Weld. It is epoxy, but we're going to JB Weld those, and we're going to probably need just a little bit more this time. So we're going to make sure we put us enough on here to fill those in. If we need more, we'll mix more, but I think that'll be close. There, that looks like 2 pretty equal amounts. I really need to get this alternator assembled and get it. Of course, my daughter's got other vehicles to drive, but she's got a house full of youngins, and she normally needs that van to haul them all, so I'm gonna try to get this bad boy back together. I ain't got much of a mixing stick, but it should do the job. It should do the job. little bit on the stick right there. Mix that up good. That's the reason I like to get it off the mixing stick and make sure there's not any small bits that ain't mixed. There, should do it. I'll get you guys turned around. Okay, that should do it. Let's do some epoxy. I'm not sure exactly what they had in this, the original stuff that was in it. I'm not exactly sure what it was, but it just looked to me like some sort of epoxy, so. It should seal it up from any of the water or anything that gets in it. Oils and evidently whatever they put in it was a little bit thinner on the viscosity than what I've got here. But that's laying out pretty nice. And we'll just try to do equal amounts. It's not that big a deal for balance, but we'll just try to get it close as we can. You know, I'm still new at doing these videos. And when you watch a video on YouTube, you don't realize, unless you do videos for YouTube, how it makes things a little bit different to do when you're doing it on camera versus doing it just getting your stuff out and doing it. Now if I can just leave it alone. Feel like I need to push this one down just a tad, because it looks like it's still kind of exposed right there. Push it down a little bit into the JB Weld. You know, it says 6 minutes. Well, I don't know if you can believe that. That's got a lot to do with the temperature. But it's below the bearing, so we're gonna leave it just like that. Let that cure. In 6 minutes it should be set up, and we'll be back and we'll move on to another part of this alternator rebuild. Okay, we got like I said, all the parts are cleaned up, and the JB Weld has set long enough to where it's not sticky anymore, but it's like 4 to 6 hours till it cures, but we won't be running the alternator before that. Well, let's go ahead and reassemble this bad boy. I'll go ahead and just start this overdrive clutch pulley on. Give it something to stand up on. There we go. Okay, let me grab the other half. See if we can go ahead and put that one on there as well. Give me just a second. Okay, we have some more parts. Back cover. All right, so I cleaned this up. Cleaned up pretty good, you can see. So remember I mentioned the wavy washer. The wavy washer. Don't forget the wavy washer. Don't forget the wavy washer. Clean it up a little bit. Now, since I got to turn this cover over to put this in, I'm just going to simply lay it right on top of the bearing, just like so. You gotta let your stator conductors come through at the proper place. I think they might have got bent just a little bit. Let me push them out just a little bit. Oh yeah. You can feel that preload in that wavy washer. Get some bolts. I'll clean them off a little bit as I reassemble them. Not that critical, but why not? Like I said earlier, if if your slip rings are still good, this is a relatively easy job. Unless you need to replace the bearings or replace the slip ring set on an alternator, it's pretty easy job. Hardest part on this vehicle is getting the alternator off of it. It's a pain in the tootie. I have a 5/16 here someplace. Here it is. You always want to tighten them evenly using a crisscross pattern. Maybe overkill, but I don't think so. Anytime there's a bearing involved, it's always best to tighten using a crisscross pattern. And I don't know if there's a torque spec on these. I'm not gonna go look it up. I broke them loose with this little ratchet, just like I'm tightening them now, so I think we'll be just fine. So there it is. Oh, it's smooth. Smooth as silk. It's like butter. Just like butter. Okay, so the next step in this process is the rectifier, the diode plate. And so I cleaned these up good, and I'm probably gonna go ahead and take a little bit of flux and flux those. I may actually try to get in there and clean it with something. Maybe a stainless steel wire brush. I have a few of those. I may try that instead. Some of the older models of these Denso alternators, or Nippon Denso, depending on the age of them, these connections are bolted. Bolt, screw, bolts or screws, either one, whatever you want to call them. They're just small and they're pretty easy to do, even easier than this one. For some reason, I guess those little screws, by not using them, it saved them some money. So since that's the case, you gotta snip them off. And we're just gonna test fit it on here for now and make sure that our conductors are lined up correctly and fit up through the way they should. And of course, this one here is being a pain in the toot. I tried not to disturb them any, but it really didn't make a whole lot of difference. Let's see if we can take a look and see what we need. Well, they're all pretty close. Tweak them a little bit. Get them more square. Plumb, perpendicular, whatever you want to call it. And you don't want to, of course, you've got this insulator here that those leads go up through, but there's an insulation on, there's a varnished insulation on these that you know, if they're brand new or you got brand new on this material, you've got to clean this varnish off or it won't get an electrical connection. we go. Now they poked up through. So that's where we wanted at, right there. I think we could just do a little bit of flux. Yep, that's it. So I'm gonna pull it back off. Clean the connections. And looking for something here to clean them with. This will just shine them up a little bit with this knife. Make sure it got nice bright copper. You can't even see that. I'll tell you what, let me get these cleaned up and I'll come right back. Okay, so we got them cleaned up. Got the rectifier plate, diode plate back down on the conductor. So now we're just gonna secure it with the screws. I'm gonna tighten them up. These screws, these Phillips screws, they're pretty shallow. They're fairly easy to strip out, so you want to apply a little pressure to them when you tighten them. If not, they will strip out. They're just that shallow. There we go. This one you might want to leave loose. It's by the voltage regulator. Just because the brush cap goes in there as well. So we got it tight. So we'll tighten all these at the same time. Now let's try a little flux. And we'll do a little soldering. I don't know how long I've had this can of solder. I appreciate you guys watching my videos. I try to put content on that I feel like will be helpful to others. There we go. With flux. Let's see how this does. this thing works out okay, it'll be great. Oops. Easy there, Joe. It's taking a minute to get that hot. It's a lot of material. It's getting there though. Yeah, it's taking a while. I think it's ready now, finally. Yeah. See if we can get this one nice and hot. There we go. It's hard to get a lot of surface contact on this. And it don't want to be still. Mm-hmm. I like him much better. I might hit those others, first two I did. Again. There it goes. Finally taking some. Yep. It's teensy stuff. A little snippet. Mm-hmm. Yeah, those look pretty good. I'm gonna redo these right here. Add just a little bit more to them. Mm-hmm. That one might be good enough. I think we're gonna leave it right there. Looks like they're all, looks like good hot joints. It's flowed down in between the conductor and the, yep. And so we'll call that good. Down to a brush holder. That's the brush holder. You can see the brushes in there, spring loaded. It's 2 of them. They fit down over the slip rings like so. So you've got this little hole. You can see that little hole. That's to allow you to stick a small wire of some sort down through there and block the brushes back so that you can get them down over the slip rings. So let me see if I can find something to do that job with. Might need to get a small. Let's see here. With some torch tip cleaners. I think that'll work nicely. Find out which one we like the best. Oh, it's, yeah, I think we might go with that one. So I'm just gonna stick my pinky up in there and get this down bottom, and then I'll show you what it looks like. So you can kind of hold them down with that. That's the idea. Let's close these up. Just like so. That is it. Drop those in. That's the shorter Phillips. How about that? This one's kind of cool. It's got a clear cover over it, which I guess all of them do. I don't know what the purpose of it is. I don't know. I really don't know what the purpose of that is. I guess maybe if you were testing it, you could see the sparks. I don't know. I don't really know. But that's kind of where it's at. This is the voltage regulator. I believe this voltage regulator is good. I've got no way of checking it. But what I plan to do is I'm gonna get this all together and I'm gonna take it probably to one of the local parts stores here that has an alternator tester where they can bolt it in there and spin it up and make sure it's putting out properly before we put it back on. If it's not, the only thing left to replace is this voltage regulator, and you don't have to take none of this apart to, you know, you don't have to do all this just to change the voltage regulator. You have to snip that connection right there. I don't know if I can zoom you in. I'm not real sure. Anyway, there's a soldered connection right there. And then you've got this one screw right here. You gotta take that screw loose. Actually, you gotta pull the brush holder back up off of there to get this off, but there's 4 screws here. We'll get your voltage regulator off once you snip this connection. Okay. Really all that's left on this is put the cover on it. And that's all that's left. So we have this device here. This is the little guard that goes over this to protect it from getting any kind of, keep it from contacting that, because that post there, when your battery's hooked up, that post is hot all the time. Yep. That just fits down over it like that. Easy, easy peasy. Put the nuts on it. They're 5/16 by the way, for the case halves. Those bolts and these nuts are 5/16. There we go. One alternator repaired. The only thing I've got left to do here is this overrun clutch. Tighten it up. Don't have any torque spec for it. I broke it loose with the impact. Takes a 17mm hex. There's a special tool that you can get to use, but there's no need for that. It just needs a couple of hammers with that impact, and it's not going anywhere. You can check your overrun clutch. It should turn in one direction. It should slip. So you can see I'm turning the alternator, but the outside of the pulley isn't moving. You can see it is now. If you can tell it on that. You can see it's pulling. And if you hold it, you can feel the clutch. It shouldn't turn back that way any, so that's what you got. And there's a cover that you almost, it's really hard to get this cover off without damaging it. It's hard to get off. And it's important that it gets put back on. I'm gonna have to order one to replace it with. They're kind of hard to find by themselves, but I believe I've located one. I just gotta measure this one to be sure. But it basically just snaps in and seals any contaminants or anything from getting inside your bearings for your overrun clutch. Anyway, that's pretty much it. I appreciate you guys watching. I hope you find this video useful. And if you have any questions or comments, by all means, please make them. Post them up on the video. Please comment. and like and share, and thanks for coming back to watch one of my videos, and y'all have a good day.